Hello again, everybody. This is Steve, coming to you not with another puzzle, but with a solution possibly to three of the puzzles that we've already done. And this is brought to me by a friend of mine recently, and this is really actually an interesting solution and solves a bunch of problems. Um, if you remember, this one here we used ram pumps to get the water up into the top. Then we have this one, which used a ram pump to get it to the top. But then we had, what we had to figure out. What are we going to do with all this water down here? Well, here's the electric motors up to the top and stuff. And then this one used the chain pump to pump the water out of the well. What if there's a simpler, easier way to do this? One of the things that they do have out there with windmills is they have what are called windmill compressors. Basically, they are, and I'll explain why I'm talking about a compressor in a second here. But you have a windmill compressor, which is basically a 1, 2, or 3 chamber high pressure air compressor that runs off of a windmill. A lot of the ones I've seen sit up here where the fan is at on the windmill, and then you have a hose down here, and then it goes over to a tank or whatever to store your compressed air. You can also have the kind where you just have the gearbox up here, goes down to a block here on the ground, and runs the compressor that way off of a drive shaft. You still get the same result. The only thing you got to have down here then is just that 90-degree gearbox that I mentioned in this particular puzzle right here. That 90-degree gearbox, would then turn your compressor, and compressor goes generates compressed air. And for the volumes you're going to need, what you would be best to do to store sufficient enough compressed air would be to get a 500-gallon propane tank. Don't fill it with propane, obviously, not unless you want yourself one heck of a bomb when you start using it for compressed. Well, in other words, if you put propane in it and then you start throwing compressed air in it, you're going to have yourself a backyard mini nuke, basically. But that's beside the point. You can use a propane tank as a pressure tank for storing compressed air, because those have a 250 psi maximum working pressure, and for what you're going to need, that's more than enough. And you could rate your compressor at, say, I would probably say run it no higher than 200 psi. You could run it at 150 psi because you're not going to need more than 150 psi. But if you want the extra pressure, which will give you the extra volume, so if you could have a whole bunch of drawdown and still have plenty of pressure to run your system, so you could run it at 200 psi, and run the windmill. It runs the compressor, it fills the tank up, and then it runs your pump. Now, you're probably sitting there going, "What in the world are you talking about? Why would you have compressed air for a water pump?" I'm guessing a lot of you have never heard of the fact that there is such a thing as a compressed air water pump. You're probably sitting in your mind going, "Wait, what?" Yes, they actually have compressors. They actually have water pumps that are powered by air. Now, there's several different types. They have rotary compressors. Rotary being like if you've ever worked with an air tool, that the air pressure that goes in runs a piston system that turns the drive shaft, and you run your ratchet that way and stuff. You got the diaphragm type that go in and out and pump water. You've got the air piston type, which basically you have a piston that is pushed in and out by compressed air, and that pumps water. Well, this one is designed to go down into a well and pump water using compressed air with very, very few moving parts. The only moving parts is actually a valve, and that's it. Well, a pressure valve and a foot valve. But anyways, the basic premise here is you have a this thing's going to be a jerk. I'm going to have trouble getting my mouse up there to highlight those things. But you have a compressed air line here. It comes from up above or wherever your source is. Then you have the drive pipe, which all of your water flows out of. connected to that high pressure air line, you have the valve box. On one side's the pressure line, the other side's the pressure relief. This here is a float rod. Basically, it's got a stop on the top, a stop on the bottom, and then you've got your weighted float in the middle. What happens is, when this thing runs, it starts out with a float at the bottom, which turns off the pressure side and opens up the pressure relief side. Once the pressure inside equalizes, then the water pressure out here pushes the foot valve open, and that starts filling up. Once it gets to the top, it hits the top side of this, changes the position of the valve, and now it closes the relief valve and opens the high pressure line, which then brings high pressure air inside. That then pushes the water down, closes the foot valve, pushes the water down and out of the drive pipe until you get to the bottom, click, rinse, repeat. One thing I don't have in this illustration that you will have on a pump like this, he's just being a jerk, is you will have on the top part up here, just above the pump, you will have a check valve. The reason for the check valve is, if you don't have the check valve there, every time the system goes into the reset mode and releases all the internal pressure, all the water you just pumped out is going to come flowing back in. So the check valve is going to keep it from coming back in to keep your system under pressure. And then you can have above this, you can have like an accumulator tank inside your house, so that even if this thing's in its reset mode where it's filling back up and it's not actually pumping any water, you've still got water pressure in the house. Now where this would be handy is like with that design that I had that was the spring. That one you could have the windmill on the top of the hill where the water tank is at, because you want it where it's going to have the best visibility to wind. For the mine one, down just right where it was at, you just change out the chain pump for a compressor and a storage tank. And same thing with the first example. You don't even need the water tower or the ram pumps at that point. You just take the pump that's actually pumping water, take that out, leave the well, but then you stick the air powered water pump into there, and then that could just pump it into the house. And it, of course, it breaks the metrics of the original puzzle and the requirements and stuff, but if you're looking at it from a practical standpoint, not a puzzle standpoint, now you're talking about something that becomes entirely practical. And the nice thing is these are easy to DIY. I mean, you could buy them if you want to. They're kind of hard to find, because this kind of pump is very rarely used, as in low demand, so it's kind of hard to find. You have to, I think the last place I saw one was an off-grid, it's one of those off-grid supply places. They do like the solar-powered water pumps and stuff, and air-powered water pumps was one of them. Was one of the things they offered. Like I say, those are kind of made to order, which means they're also not hard to produce. If you're good at welding, or somebody who's good at fabricating, one of these is not hard to do. You could put it down a 6-inch well casing. You probably want it no more than probably 4.5 inches wide, because you have to allow water to flow around it, and it has to be able to fit down the pipe fairly easily, or down the borehole fairly easily. So if the borehole was 6 inches, you probably want that no wider than 4.5 on the outer diameter. But yeah, this is really easy to put together. It's really simple. It's self-maintaining. The wind-powered compressor, the compressor that's run by the windmill, that, like I say, you can have that up on the tower, as a lot of them are, or you can have it on the ground and have just the gearbox up top that goes to the drive shaft that then runs the pump. The reason I'm thinking that the pump is better on the ground is that compressors go through a lot of oil, and you don't want to have to be hauling your butt up there on the top of that compressor, or on top of that windmill, to go up there and top off the oil in the compressor, especially if it's like windy and stormy and your compressor's not running, or this thing's screaming like a stuck pig or something. You're better to have it on the ground. Just walk by, flip the cap, okay, there's some oil, flip it shut, and off you go. makes maintenance really easy. And if the gearbox up top is sealed and it's done correctly, that 90-degree gearbox should run for 30, 40 years without ever needing to be replaced. You should never have to service that. But anyways, yeah, that's basically how easy it is. Windmill to a 90-degree shaft, down a drive shaft to a air compressor pump, compressed air out to, like I said, my suggestion was a 500-gallon propane tank. And I would set your compressor maximum to 200 psi. Now, if your compressor only does 150 psi, that's fine. 200 psi is best. The reason I say 200 psi, 150 to 200 psi is, let's assume that you're not taking out of a tank, like in the desert example. Let's just say you've got a well that you're down 150 feet. Well, you've got to have the water, or you got to have the air pressure to lift at that 150 feet, which 150 feet, if I remember correctly, so 100 is 40, so 50 feet would be 20, so you're talking 60 psi just to get it to ground level, and another 40 psi just to have proper house pressure. So you're going to need 100 psi right there, and if you run it at 150 psi, you've got your 100 psi to keep your house pressure up and keep your pump working. Because if you're, say your house pressure is 40 psi and your well pressure from the pump to the top is 60 psi. In other words, you need 60 psi just to get it to ground level. If you only have 100 psi in your tank, your pump's going to stop until your water pressure drops enough that it can actually start pumping, and then it's not going to pump at all that great a speed. So you got to consider that. You want to have that extra psi for the extra pumping power. Now, how do you regulate that so that it's always 120, 125 psi going down to the well? I would say, if it's 120 psi to get 40 psi, you probably want 125 psi. Just so you got that 5 psi extra that you can you're not having to wait for, like it to drop to 35 or 30 psi before this thing really starts replenishing the system. You're going to have that extra 5 psi for it to go back in and start pushing water back into the system, bring your pressure back up after you start using water. But yeah, you set a regulator to 125 psi. It doesn't matter what pressure your tank is. It's what the regulator does. And the regulator doesn't have to be super fast. It just has to allow the pressure to be 125 psi and you're good to go. But anyhow, that is an additional way to solve this in a practical way that's outside of the puzzles. Now, I mean, yeah, it breaks the puzzles. But if you're looking for a solution that's practical and real world, this is a practical real world solution, which is some of what, part of the reason I like those puzzles is I'm always looking for how can I do this in a practical real world configuration that I would actually use if I was out if I was actually out living somewhere like in the woods, on my own homestead, whatever like that, and I needed everything to be mechanical. And again, the nice thing about this is you turn it on, you walk away, you don't touch it again, except maybe to top off your compressor's oil every so often. Other than that, it's completely hands-off. So, anyways, that's my presentation. If you have any questions, comments, concerns, ideas, suggestions, please let me know as always. Thank you.